oxidation with cleavage of just only one bond of the double bond. Number 2, oxidation with cleavage of both double bonds. Now, what do I mean by this? Now, the first one, it's a case where you oxidize the alkane and one of the bond out of the two breaks, just one of the bonds. And the second case, two of the bonds breaks, like the alkane split into two halves. And what actually determines whether it's going to follow the first one or the second one depends on the nature of the reagent. If you use a very harsh or strong reagent, it cuts the double bond into two halves, right? If you use a milder or weaker reagent, it's just going to break the pi bond. Now this guy is a case where I have something like this. Now this breaks and then leaving it to just one bond. Whereas in this case, this guy breaks and this carbon, this two carbon now stand separate. So that's take note of that. Oxidation with cleavage of just one bond of the double bond, and oxidation with cleavage of both bonds. Please, sorry, this of both bonds of the double bond. Oxidation with cleavage of both bonds of the double bond. Full stop. All right, so let's look at this. So that let's look at this guy. Oxidation with cleavage, oxidation of alkenes, oxidation of alkenes with cleavage of just one of the bond of the double bond. Like you have this guy, the first oxidation will just break one of the bond and leave behind the other guy. Please look down. The reagents that is used in executing this type of oxidation are as follows. The reagents used in executing this type of reactions are as follows. Number 1, we have an acid, and this guy has. Number 2, cold alkaline KNO4. Number 3, now these are the 3 reagents. Per acid, now the reason why we call it per acid, normally carboxylic acid is always COOH. Anytime you hear per means there is an introduction of extra oxygen. So this guy initially was 2, is 2 oxygen. Normal carboxylic acid is a general formula. Now per acid means per carboxylic acid, oxygen increased to 3. The same thing as this is water. Per oxide, this oxide of water, oxide of hydrogen. They said per oxide, the oxygen increased to how many? So next time you hear per, there is always extra oxygen most likely going to be added. So I think this per acid. Normally, if I have something like this, CH3COOH is called ethanoic acid. This is ethanoic acid. But if I come here and increase the oxygen to 3, this becomes per-ethanoic acid. So take note of that. So the reason why we call it per acid is because there is extra oxygen that is added to Take an oxidate acid equation. Alright? Alright. Oxidation of alkanes with per acid. Oxidation of alkanes with per acid. Please put down. Per acid oxidizes alkanes to epoxides. Per acid oxidizes alkanes to epoxides, which opens to give trans 1,2-diol. Which opens to give trans 1,2-diol in the presence of aqueous acid or base. In the presence of aqueous acid or base. So we have this. Now, if you look at this guy, now this is alkenes. This is per acid, RCO3H. Now this is going to break one of these bonds and form epoxide. So we have, how does epoxide look like? That extra oxygen that was added here will now be released. This is how epoxide looks like. Now when you add water to this guy, this will now open up to give trans diol. So in other words, per acid oxidizes alkanes to epoxides. This is actually what you have here. This per acid oxidizes alkanes to epoxides, which opens to give trans 1,2-diol in the presence of aqueous acid. Once it opens up, water is OH and H. If this guy opens up, this H adds to this guy, and the OH goes to the opposite side. We now have trans, and trans means that they are both on the opposite side. I will refer to this as trans because the OH on the opposite side. This is trans 1, 2, 10-diol. Now, I'm only interested in the 2 carbons of the double bond. What does this mean? It means that they can even choose to give me something like this. They can choose to give me something like this. And then RCO3. Bear in mind that this R can be CH3, can be any alkyl group, HCl, or as the case may be. All I'm interested in is just this double bond here. Break this double bond, this guy becomes, because some persons, if you see something like this, you start panicking. This becomes this. Finish. The double bond here breaks. One of them stretch out and we put the O here. And if you add water to this guy, this becomes OH. To show that they are trans. But if you cannot do this, you can just write it out normally. Just put your arrow, draw it out, and draw it out. Reaction with cold alkaline KMNO4. Please put down. Cold alkaline KMNO4 oxidizes alkanes to a 6-diol. Oxidizes alkanes to a 6-diol. Oxidizes alkanes to a 6-diol. So this becomes, we take an example, CH2, we have KMNO4, cold alkaline, or we can just write like this. Please, they must indicate, because in this particular oxidation reaction, there's what we call hot. The work of hot KMNO4 is not the same thing as what? Cold. So they must always indicate. Hot is always acidic. Cold is always what? Basic or alkaline. So this is what we're going to have. This guy breaks the bond, puts OH on the same side. Any compound that has two OH is called diol. If you want to name the diols are named as alkane. You spell the alkane complete and then add the word diol. Now, the position of the diol can be written in front or in between this alkane and diol. 2-carbon alkane is what class? Ethane. So I can say ethane 1,2 what? Diol, or 1,2 ethane diol. What if they give me something like this? This alkaline, cold alkaline KMNO4. My only interest is that, once I see KMNO4, I know it's oxidation reaction. This oxidizing agent. Once I see OH minus, I know that this guy is cold or mild condition. And mild condition can only break one of the bond. And once it breaks one of the bond, it's going to put OH on both sides to give you a diol. This becomes OH, cyclohexane, and 1,2 cyclohexane diol. Okay, this guy also gives cis-diol. Sorry. So it's only the acid that gave or that will give us trans-diol. KMNO4 gives cis-diol. Osmium tetraoxide also gives us cis-diol. So let's use this guy. Now look at this. This description says oxidation of alkane using osmium tetraoxide followed by treatment with this in an alkali to give cis-diol. So it's a two-step process. This is 1 and this is 2. So instead of me to actually first of all carry out this guide, because normally you have to do this stepwise, I'll first of all write this one, get my product, draw another arrow, put the second guide, get my product. So for the first that we said 1 and 2, they might decide to just use the word format. If the product of the reaction went into alkane, it's oxidized using osmium, followed by the treatment with this. Now this is going to give us a cis-diol. Come here, write your product, put OH here, and put OH here. Now, this type of oxidation of alkenes are achieved by the use of the following reagents. This type of the oxidation of alkenes are achieved by the use of the following types of reagents. Number 1, hot, acidic, KMNO4. Now this guy is potassium. The common name is potassium permanganate. But the aliphatic name is potassium tetraoxomanganate 7. That's the aliphatic name. Now take note of the reagents. Now the second guy is ozonolysis. Now, ozonolysis is a breaking of bond using ozone. The breaking of bond using ozone. So anytime you see lysis, I told us the last time, lysis, this stuff you're seeing here means break. So ozonolysis means breaking of bond using ozone. Now we have two types of this. We have the first one by we have oxidative ozonolysis, and we have reductive. I just want to make it straight. In your textbook, there's nothing like this, and you're not going to see of today, but the products of both of them will differ. Now, how do we achieve ozonolysis, oxidative ozonolysis? Please stop writing and look up. Now, this is achieved by the use of ozone and peroxide. Anytime you see ozone / peroxide, it means that this guy is ozonolysis followed by oxidative walk-up. Now the second guy is what we call reductive. Now this is ozonolysis followed by treatment with zinc in an acid. This is something like treatment in zinc in an acid. Now I'm going to actually show us how they can present it in exams, right? Now this is zinc in an acid. The acid can be acetic acid, or you can be just use normal H plus. Or they can use acetic acid. Your textbook, some textbooks might use this. Now this means acyl group, with OH you have acetic acid. So I'm just going to explain this shortly. So note this, that this, for you to break the two double bonds, right? These are the process involved. So here we have hot acidic KMNO4, right? This is potassium permanganate. Now the second guy is ozonolysis. Breaking of bond using ozone. This guy can be carried out in two ways: oxidative cleavage, reductive cleavage. You're not going to see this inside your passbooks or inside your material, but I just thought it's white, or it's okay for me to say this so that you know the difference between O3 / H2O2 and O3 / zinc in an acid. They can actually give us this directly, or they can use word format. Give the product of a reaction when so alkane is treated with ozone followed by treatment with zinc in an acid. That is reductive ozonolysis. Right? So, note, please note inside your material. Note the effect of hot acidic KMNO4 on an alkene. The effect of hot acidic KMNO4 on an alkene is the same with oxidative ozonolysis. Is the same with oxidative ozonolysis. The effect of hot acidic KMNO4 and oxidative ozonolysis is the same. They both give rise to the same product. If you have something like this, and then you have hot KMNO4. Now, the moment you see hot KMNO4, any of those reagents I gave to us, this is the first one. The second one, this side to be written in exams, both / this, or the peroxide can come below the arrow. Now, the third one, most of the times, is always like this. This is how they write the third guy. Now, they now say zinc in an acid. Sometimes they put it this way, or you can see something like. Now this is ozonolysis followed by treatment with zinc in an acid. Ozonolysis followed by peroxide. These two guys, they give rise to the same product. They do the same thing to this reactor. So once you understand the use of hot KMNO4, it's the same thing as this guy. So this is what it's going to do here, class. It will cut this bond into two. First, we expect something like this: CH3, CH plus CH3, CH. That is how it's going to look like. Now, after cutting the bond into two, it's going to convert them to either aldehydes. Listen, it's going to convert it to either aldehydes, ketones, or carboxylic acid. Now, if after doing this guy, listen, and this carbon of the double bond, these are the two carbons of the double bond. If this carbon is having one hydrogen, like I can see here, this will convert it here to carboxylic acid. And what do I mean? It will just put two oxygen in the middle. That is the work of this guy. After cutting this guy into two, all of them, this and this, they will cut the double bond into two. But the products this guy is going to give, right, will actually not be the same as these two guys. So once this guy has one hydrogen, the effect is to add two oxygen here to convert this guy to carboxylic acid. Same thing here, convert it to carboxylic acid. Now, if this guy, please don't write it, just look up. If this guy has no hydrogen here, let's assume this is like this. If I have something like this, now this becomes, this is what we're going to have. If there is no hydrogen on this carbon, after breaking this bond, it will convert it to ketone. Ketone simply means add just one oxygen here. The side that has one carbon converted to carboxylic acid. So these three reagents can either convert to aldehydes, ketones, and carboxylic acid. But let me tell us something now that distinguishes this guy from the remaining two. If you're using hot KMNO4 and you're using this, they will never give rise to aldehyde. They can only give rise to what? Ketone and what? Carboxylic acid. The only guy that gives rise to aldehyde is this guy. If hot KMNO4 slash ozonolysis followed by peroxide, that is oxidative leaving, is used. Now let's see the effect of this reagent on an alkene. How is going to convert the alkene to the product? So I said, if the first one, if hot acidic KMNO4 or ozonolysis by peroxide is used, please put down. This reagent splits the alkene into two equal halves. This reagent splits the alkene into two halves, comma. This reagent splits the alkene into two halves, comma, and subsequently converts each half to either a ketone or a carboxylic acid, and subsequently converts each half to either ketone or carboxylic acid, and subsequently converts each half to either ketone or carboxylic acid, depending on the number of hydrogen on the carbon of the double bond. Depending on the number of hydrogens on the carbon of the double bond. Full stop. A. If the carbon of the double bond have one hydrogen, if the carbon of the double bond have one hydrogen, it will be converted to carboxylic acid. It will be converted to carboxylic acid. Now, before we take the second guy, I'm going to give us a series of examples so that this guy will stick. But let me just take the second guy as well so that B if the carbon of the double bond, B, if the carbon of the double bond has no hydrogen, it will be converted to ketone. It will be converted to ketone. I have CH3, CH, now, and then I have hot KMNO4. Once you see this, it will split this guy into two. Now remember, this is the carbon of the double bond. After splitting this guy into two equal halves, it's going to convert this guy to either a ketone or a carboxylic acid, depending on whether this carbon is having one hydrogen or no hydrogen. This guy is having one hydrogen, you know so? Yeah. So after converting this, after breaking this guy, don't do that side. After breaking this guy, it will convert this guy to carboxylic acid. That's COOH. So this guy is going to give us 2 molecules of carboxylic acid. Now look at this. We have CH3, CH, right? Plus, I'm going to, instead of me to say CH, CH3, I'm going to rewrite it. It's still the same thing. So this becomes CH3 and what? CH. Remember, this is still the carbon of the double bond, so put asterisk there. Now, after splitting this guy into two equal halves, if the carbon of the double bond have one hydrogen, right? It will convert it to what? How many hydrogen do we have here? Carboxylic acid is C what? So this guy becomes O what? H. Now look at this other side. Is this carbon having one hydrogen? Yes. So it will do what? So that is it. So most times in your textbook, you may not see it this way. They can just come and say 2 molecules of what? Because if this is 1, 1 plus 1 will give us what? 2. So this is a product here. Right? Now there are times they can mix the one that have one carbon, no carbon. So I'm just going to take that one after the other. Remember, class, bear in mind that hot KMNO4 is still the same effect I'm going to have if I decide to change this guy to this. O3 slash what? Take note of that. If I remove that hot KMNO4 and put this, I'm going to have the same thing. The same. That's now the other, if I use zinc, I'm going to tell us how that guy will work. So let's look at the second example. If I have CH3, now and I have this guy, and I have hot KMNO4, which I can still replace with ozonylysis with peroxide. Next, this guy will split this guy, but before I do that, this guy is the carbon of the double bond. Is this recorded? Alright, so when you split this guy, right, this is what I'm going to have. CH3, C, CH3. This guy, seal the asterisk. Plus, I would have simply said C, just write it the same way, but I would have done this, but let's write it properly, do not slow. I will turn this guy to now become CH3, C. Don't forget that this is a carbon of the double bond, is not slow. Is this guy having any hydrogen here? No. Of course, from this alkene there was no hydrogen, is it not so? So it will simply convert it up. If the carbon of the double bond has no hydrogen, right? After splitting it, it will convert it to what? To ketone. And what is the functional for ketone? Right? So this guy will just come here and put this guy here. And put this guy here. But in your textbook, they might write it in a way that is not like this. If I want to write this guy, please come. This guy can be written as this. I can write this guy as this, C. I can say CH3, C double bonded to O. You know this is something as this. So this I'm going to see it. And this guy is CH3. Please, this I have CH3, C, CH3. Now look at this. Look at this example. Now this is two. This is very common example question. If you take to your past question, it's length. Now, what's the noise for? So now look at this. This particular question here is a very common question for exams. 2 methyl with 2 in. Now, sometimes you can say ozonolysis followed with peroxide. Do not forget that this is the same thing as saying hot cheminophobe. The same effect, the same product. Now, the 2 carbons of the double bond, I'll put the asterisk. The effect of this guy, ozonolysis, first is to split this guy, is a must. The reason why we say this guy is oxidative cleavage, after splitting this guy, this peroxide will oxidize this carbon, add oxygen. Now this guy has no hydrogen, so it will be converted to ketone. This guy has one hydrogen, it will be converted to what? So this is what we are going to have. This is CH3, C. If I do, okay, let me do this so that to avoid confusion. Now this is it. Now this is the left hand side plus. Our right hand side, I'm going to write it. We have CH3. Now look. This guy has no hydrogen. Here has one hydrogen also. Yes. The rule says if after splitting this guy into 2, if there's any hydrogen here, it will convert it to carboxylic acid. And what's carboxylic acid? If it has no hydrogen, it converts it to what? So it becomes. I would have done when it has 2 hydrogens, but that one. Now let's see the effect of ozonolysis, reductive ozonolysis. That is, if I'm using O3 in the presence of zinc and in an acid, alright, followed by treatment with zinc metal in an acid. Now, reductive ozonolysis. Now, these are the various ways you can see this in a reaction. You can see O3, Zn, H plus. You can write it this way, or you see O3, zinc. Now, this stuff stands for acetic acid. So once you see this, ozonolysis followed by zinc metal in an acid, just know that this guy is reductive ozonolysis. Now, how does this guy work? Let's look at the principle of this guy. Reagent will split the double bond into 2 halves. This reagent will split the double bond into 2 halves, comma, and convert each halves to either aldehydes or ketones, and convert each halves to either aldehydes or ketones. The first 2 reconverted to ketones and carboxylic acid. That means this guy does not ever convert anything to carboxylic acid. Now, this reagent splits the double bond into 2 halves and converts each half to either aldehydes or ketone. Now, if the carbon of the double bond, is having 1 hydrogen, it will be converted to aldehyde. Now this is the major difference between this reagent and the previous reagent when it has 1 hydrogen. If it has no hydrogen, it's still the same thing like the previous 2, right? But once there is 1 hydrogen, this guy is not going to allow this guy to oxidize to carboxylic acid, because if you oxidize aldehyde will go to carboxylic acid, but this will not allow this aldehyde to get to carboxylic acid. So that's the difference. Number 2, it's still the same thing like the previous 2 reagents. If it's having no hydrogen, it will be converted to ketone. Please bear this at the back of your mind that most of the times this is always given to us in terms of word format. I'm going to read out the question. Thank God I have past question here. So you can see how this can be asked. Now look at this. This is ozonolysis followed by treatment with zinc in an acid. Now, this ozonolysis is going to split this guy into two. So that we have. Now, for me, I don't have to be writing it down. Once I look at this guy, I already know what this guy is going to give me. So also, this guy has no hydrogen. So after splitting this guy, I'll put just 0 here. So this becomes CH3, C, CH3 this. But in exams, I'm not going to write this like this. Right? In exam, this should be written like this. This for this side. For this side, this guy has just one matrix also. That will say plus CH3. Please, it's not going to be carboxylic acid because it's reductive. It's going to be aldehyde. CHO, which can be written as. Thank you. So this is ethanol. And this is propanol. So please write this. This is actually 2-methyl butene or 2-butene, right? This is 2-methyl 2-butene. This is the structure on the board. So if you take this thing serious, you might just realize that you get to exams from the example I've been doing in class don't have to be your exam question. Let's attend these questions. Now this guy is not given, but this is oxidative cleavage. Split this guy. This will give us ketone. This will give us the carboxylic acid. Along. So we have CH3, CH2, this guy is CO. I'm going to write it here properly. Plus, and this more like CH3, CH, CH3. Now this is CH2 also. Now this guy is oxidative, so this becomes what? COH. So I can write it here properly and put this CH3 by the side, and this becomes I'm not going to spend